Okay, so we're going to use this table A thing. This will be provided for you on the exam in the event, of course, that you don't have a calculator. And even if you do have a calculator, this is what table A is. So pull out this sheet. It's the very front side of your stapled sheet. Who's humming? I want you to try B. See if you can figure that out. When you're done, compare with two people. Remember, probability, area, proportion, percentage, those things are all referring to the same thing. Shaded area under the curve. No calculator is necessary. As soon as you find the answer, compare with two people. Should take you less than 60 seconds. Okay, time's up. So here it is. This is how it works. I'm looking at my table here, and I'm looking for the likelihood that something's going to fall less than 0.72, which is negative. So as I look at my normal curve, again, I like to draw pictures all the time because it's very helpful for me visually. So here's my mean. Here's negative 0.72, I think they gave us, and they're looking for this information. I know that the table tells me everything to the left of whatever that data is. So in my table, I look for negative 0.72. So here's negative 0.7, 0, 1, 2. The answer is 0.2358. Done.
What does that mean?
That means 23.5% of the data falls below negative 0.72 standard deviations.
Wow.
But how do you try them?
Okay, so here we go. Let's try again. So as I draw a picture, because I said pictures are very helpful, what I see is the following. I see my density curve. I know that here's my mean. Here's negative 0.72. I'm looking for all of this data over here. And when I look at my table at negative 0.7 and then 2, I see the number 0.2358. This is indicating to me that 23.5% of my data falls below negative 0.72, standard deviation is below the mean. Or in other words, the probability that my z-score is going to be less than 0.72 negative is equal to 0.2358. Now there's a cool way to do this on your calculator as well, and I'll show you that momentarily. You try letter A. So in part A, as I draw my picture, and I look at the density curve, also called the normal curve, the number they give me is this 1.65. And it does not matter whether or not they say greater than or equal to or just greater than, it'll work out to be the same. This time, this is the shaded region that they're talking about. As I look at the number from my table, and I see that they talk about 0.9505. Is that the right number? They are talking about the white region. I don't want the white region. I want the shaded region. But the area under our density curve totals up to 1. So the probability that my z-score is going to be greater than or equal to 1.65 will be equal to 1 minus the 0.9505. Or in other words, this area right here is 0.0495, and that's my answer. Okay, one last one for you to try. I want you to try C. Okay, as we look at this very last one, and we draw our picture with the normal density curve, with the mean on there. One of the numbers they give us is negative 1.32, and the other one they give us is 2.15. If we look at the amount of data that is below 1.32 from this point to the left in our table, we see that that number is 0.0934. Did I get that right? If we look at the amount of data that is below 2.15 from our table, we see that that information is 0.9842. So in order to find out the probability that all of my data is somewhere between these two things, I would say that the probability that my z-score is going to be in between negative 1.32 and 2.15 is the value that I get when I subtract those two numbers, which I get as 0.8908. So let's see how to do this on our calculator. I'm going to start with A and then move on. So in A, when I go to my calculator, I noticed that when we were talking about this, we're talking about the amount of data that was above 1.65. The way that you do this is you go second, vars, and you'll see a list of things. You want to go down to number 2, which says normal CDF. Normal CDF. Hit enter. And the number that you're starting with is that 1.65. So I type in 1.65. And then you want to go on forever, standard deviation wise, to the right or in the positive direction. Now that's really positive infinity. But we're not going to put in positive infinity in our calculator. Remember that 99.7% of our data is within 3 standard deviations. So there's a minuscule 0.15% beyond 3 standard deviations. So what I like to do is I like to put down comma 99. That's 99 standard deviations beyond the mean. I mean, that's virtually 100% of your material. And will be good enough for you on the exam. And the parentheses, hit return. And you will see how to get the percentage, 0.0495. So on my paper, if I was doing this, I would write down normal CDF, and I'm going 1.65, comma, 99, and it yields the same thing. So this is a very fast way to do this on your calculator. And in this class, if you can use your calculator, use it. Saves you a lot of time. Okay, so in part B, the way that you would type this in your calculator would be normal CDF, but in the parentheses, you would put negative 99, because that's the lowest value that you would want, up to negative 0.72. And in the orange, you would type in normal CDF, and then you just write down the two numbers you're in between. So negative 1.32 and 2.15. Now if you want these negative 99s, which are representing infinity, you could go 3, so you go 999 or negative 999 if you're concerned about your accuracy. I don't think it's going to be necessary, but if you want to be right on, super accurate, I guess, 999 or negative 999.
Mega accurate.
Okay, so in this last part here, this is basically just about procedures. They talk about it. This kind of describes what's going on for stuff. I'm not going to read it to you. You can read it on your own. And it kind of describes what we've been doing in the last few examples. We haven't done a couple of these things, but we're going to continue on tomorrow and finish up chapter 2. So some of these things we're going to talk about how to find the percentile, the z-score, all that kind of stuff. But we'll start doing that tomorrow because this is a natural break. You have the rest of the hour.